All right, once again, good morning, grade 8, and this is our lesson about power. So, the specific objectives for this lesson are the following. The first one, define power. Second, solve simple problems related to power. And lastly, describe the relationship between work, force, and power. But first off, let me just ask you this. Now, what is the work energy theorem? So again, what is the work energy theorem? So I'll give you some time to think about this, right? So and then let me just explain what the work energy theorem is. All right. So the work energy theorem basically talks about the relationship between work and energy, okay, as manifested by these two hands that seem to be congratulating each other. So that's the relationship between work and energy. Okay, how is this so? So we can go back to the concept of work or to the work formula where you see that a net force is able to do work on an object, okay? And then when the force is able to do that, there's actually a change, or there will be a change in the velocity of an object, where again velocity is the speed with direction. Okay, and then this change in velocity of an object will further give a change in kinetic energy. Okay, a change in kinetic energy. Why is this so? So if you recall the formula for kinetic energy, that's equal to 1/2 mv squared. So you see the v in that formula. So that means kinetic energy and velocity have a direct relationship. So what happens if there's a change in velocity, there will also be a change in kinetic energy. Okay, and then this change in kinetic energy is actually what is known as the work energy theorem. Okay, so you can also get the work done if you look at the final kinetic energy and the initial kinetic energy. So you just subtract the initial from the final, or in other words, kinetic energy final less the kinetic energy initial, then you will also be able to get the work done. Okay, so in other words, this just gives you another equation for solving for work in terms of energy this time, and not just by the net force and the displacement. Okay, so that is the work energy theorem. All right, so the question now is, how does power fit into the picture? Okay, so this is what we are going to be finding out today. Okay, so let's look at what power is. Power is actually the rate, now if as you can see on screen, is the rate at which work is done, or how fast energy is being used. So from that statement alone, you can actually figure out what is the relationship between power and work, and power and energy. So in terms of work, power is just the rate at which work is done, or how fast or how slow work is being done. No? So in that case, you would need the value for work, and you would also need the value for time, because we're looking at how fast or how slow. Okay, so that's a relationship between power and work. How about power and energy? So you can also look at power as how fast energy is being used, no, as an object does work, or as a force is being done, or as work as being done to an object as manifested by the force. Okay, so that is the relationship between power and work, and power and energy. So in other words, you can just think of power as the rate of doing work. So that's the simplest definition for power. It's the rate of doing work. Okay. So I got this illustration from the internet. So this is not mine. I just searched for it via Google. So this just basically shows us the formula for power, and that's just work divided by time. Because again, if you go back to the description or the definition, work is the rate of doing work. And I mentioned to you a while ago that that requires the value for work and the value for time. Okay? So you just divide work by time, and then you will get the power, as you can see from the formula. Okay? And then just remember that W is the work done, and the equivalent unit for this is actually the joules. Okay, the joules. So please always remember the equivalent unit for each quantity. And then T is time, and its unit is the second, S. And then lastly, power. Uh, Power is actually joule divided by seconds, or joules per second, right? And there's a special name for that, and that is the watt. Okay, so in other words, work has a unit of joules, time has a power of seconds, and power has the unit of watts. So please remember those units again. All right, and of course, we also have the formula. So we have the formula for power, as indicated in our favorite, the pyramid. Okay, so if we are looking for other quantities aside from power using the power formula, this pyramid would be extra useful. Okay, so again, if we are looking for power, that's just work divided by time. Okay, if we're looking for time, that's just work divided by power. All right. But if we're looking for work, that would just be power times time. Okay. So please, again, just remember this formula. Work on top, P and T on the bottom. All right. So I guess it's time for us to solve some sample problems. So I have here sample problem 1. Manglino did not have a good day yesterday. His jeepney stopped in the middle of the road. He called for some volunteers to help him push the jeep 150 meters away from where it stopped. The amount of force that they applied to the jeepney was 1,200 newtons. They pushed the jeepney for 15 minutes. Determine the power of the volunteers who helped push the jeepney. Okay, so you have there the image of a jeepney, just for you to imagine the problem. And of course, we would need to write the given. So let me just enable my tablet. Okay, so let's look for the items that are given in here. So of course, we have 150 meters. So what is 150 meters? You have to think about that. In order to help you, look at the unit. And then we have 1,200 newtons. So again, to help you figure out what that quantity is, look at the unit. And then 15 minutes. So again, look at the unit, no? But the unit is in minutes, so we probably need to be doing some conversion, no, later on. Okay? And then we are supposed to look for power. All right. So let's start with the given. So this is again the Gauss method, given. All right. And then let's just indicate what these quantities are. So he called for some volunteers to help him push the jeep 150 meters away. So meters. So this is probably length. So this is the displacement, right? 150 meters. All right. And then 1,200 newtons. Newtons is a unit of force. So that is F. And then 15 minutes, of course, that's a measure of time. But it's in minutes, so we need to convert minutes to seconds. Okay, so just think, how many seconds are there in 1 minute? So there are 60, right? So we just multiply actually. So we have times 60 seconds per 1 minute. So this will effectively give us the time in seconds. So I just get my calculator, or if you can answer this uh, mentally, then please do so. So this is equivalent to 900 seconds. Okay? And then the unknown is just P. Determine the power, capital letter. All right. So let's solve. Okay. So we're looking for power. So just bringing back the pyramid. So work on top and then power and time below, right? So we're looking for power. So the formula will just be work divided by time, right? But looking at the given, we are actually not given the value for work, right? We're not given the value for work, but we can solve for it using the formula for work. So again, the formula for work is W equal to F times displacement, right? So I can just maybe compute for work here on the right side. So that's just equivalent to 1,200 times the displacement of 150. Again, I'm not putting the units because the units are already the units that I want them to be in, Newton and meter. So I just get my calculator, 1,200 times 150, and this is actually equivalent to 180,000, and the unit for work is the joule, J. Okay? So now we have the value for work. This is not yet the final answer. What we are looking for is power, right? So we just input this value into the power formula. So this will just be equal to 180,000. So I don't need to put the unit, but then of course you can always do that divided by time. And the time that we have solved for is 900. Okay, so right now you can actually solve this mentally now, but if you want to be sure, then you can always just use your calculator, and the answer would be 200. And then what would be the unit for power? If you said watts, then you are absolutely correct. So the symbol is W. So power is equal to 200 watts. Okay. Please don't be confused with the unit watts with the quantity work. Okay, so the big letter, capital letter W here, when it's after a value, would be the value for power. Okay, but if it's physical quantity, then that is work. So that, just don't be confused, although they use the same symbol, a capital letter W. Okay, so that's it for sample problem number 1. Let's now move to sample problem number 2. Alright, sample problem 2. One has 5 watts of power while lifting a box to a height of 4 meters. So you can see from the illustration, that's not actually a box but a barbell, but you get the idea, right? So in doing so, he exerts 90 newtons of force. How long did he do the task? Okay, so let's look at what's given one by one. 5 watts. So again, the unit is W, watts. So this is probably, or this is surely the power. And then we have 4 meters, right? So this is surely the displacement. And then 90 newtons, so newton, so that means this is force. And then the question is, how long did he do the task? Okay, so the question is how long, but this actually doesn't talk about distance, no. So it talks about something else, a length of something else, and that something else is actually time, no. So this question is asking us about the time. So let's write the given, no, completely. So power quantity equals 5 watts. So it has to be written completely. Don't just write 5 watts. And then the height is actually the displacement of 4 meters. And then 90 newtons is the force. So again, write all of your given completely with unit and quantity. And then the unknown is just time. and we expect the unit to be in seconds. Okay. And then let's just solve for this really fast. So we are looking for time. So again, let me bring back the pyramid. So we have work on top, power and time below. We're looking for time. So we can see clearly from the pyramid that that is just work divided by power. Okay, work divided by power. Again, looking at the given, we cannot find the work in here, right? The quantity work. But then again, there are other given values or data that you can use in order to solve for work. So that means I need to solve for work again using the formula force times displacement. Okay, so that is just substituting 90 newtons times 4 meters, right? So this gives me a work of 360, and then the unit of work is the joule. Okay, so this is 360 joules. This is not yet the answer because we are looking for time. So yung 360 joules that we have computed, let's just use it to compute for time. So this is just equal to 360 joules divided by a power of 5. And then we can just solve for this mentally or using your calculator. And this just gives us a time of 72 seconds. Okay, and then final step would be to box your final answer. Okay, so this is the solution for sample problem 2. We need two steps to solve for this. First step is to solve for work, and then when we have solved for work, we plug it in for the formula for power, no, in terms of time, and then we were able to solve for time. All right? Okay, so let's move on. So I just want to ask you this, no? What new thing have you learned today? So I hope there's something new that you learned today, or I hope I was able to clear up something that confused you about work, energy, and power. All right. So after we have discussed everything, well, I hope you now know the answer to this question. Can you now describe the relationship between work, force, and power? And then that's the end of our lesson for today. So I hope again you learned something new and that you were able to determine or describe the relationship between work, energy, and power. And I'll see you soon next time. My next lesson would be about, we will start with a chapter on sound and light. And once again, I got all of the word problems and the text and some definitions from the textbook, Practical Science 8 from DIWA Learning Systems. And then all of the images that I use are from Google via the search engine Google search. And then all of the GIFs are from jiffy.com. And of course, um, the Bitmoji for Chrome. Okay, so that's it, everyone. Bye. See you next time.